Be like, that's something I would do too.
But
You
know the people that are there.
So much.
Question, can behavior be genetic or is it learned?
Well,
That's fine. Okay, we'll need to talk about that.
That's not me, Jason.
that's fine.
I feel like I need to splash you with water and start yelling, the power of Christ compels you.
Better not be tap water.
Again, the fact that you're differentiating is not helping your case. Regular water doesn't do anything.
It's like that one scene on.
Wow.
So we don't have a cat.
Shocker.
But I like only want false water.
I said, where's your cat?
Are you talking about immunology?
Go with.
The test was.
How did it run away? She was gonna play with it outside. And so she had it in her yard.
Okay, projectile motion. How do we feel about projectile
I still
motion?
don't, but you know what? I
At least you're honest.
I'm so sad you couldn't make it to dance. I was really hoping you're gonna help my uncle.
Football players should be really good at projectile motion.
Why? If you're a quarterback.
Football is a projectile.
What do you think of
Yeah,
that?
but we tapped the guy with the ball. Well, at least that's what I do.
I catch it.
Okay, so
what I
then,
do.
okay, so then you just take your X and Y axis, lay it on the field. We're watching that path of motion, trying to cut it off.
Come on.
But that motion can also stop and start faster than I can, and they're also bigger than I can.
Wait, how, if they're faster and bigger than you, how effective are you at defense?
Not that effective. I don't start.
I would love to see.
I left that one blank. I ran out of time.
Watch the guy go, nope, just.
Yeah. Physics says no.
Physics said told me not to. My physics professor said not to go.
Yeah.
The chances of ending up in the NFL are very slim. I am not gonna blow my knee out forever. I'm gonna go right on by.
Be my guy.
I feel like you shouldn't.
walk off.
It's going.
Okay, so as we were talking about, you notice that your vectors now are going to have angles. So your velocity is going to be a true vector, x and y. What did we say the acceleration in the x direction is going to be? 0. What about the y, the acceleration in the y direction?
0.
9.8,
right?
In the y direction. Are you floating right now? So what acceleration is preventing that?
Gravity.
Gravity. There we go.
I thought we were neglecting.
No, only if we look. If we neglect gravity, we're gonna get some weird acceleration. Like we're gonna get some weird projectile motion. Okay, so another thing that can help you solve problems. Your velocity vector at the apex of flight. How many components does it have? One, x direction. And if I calculate my Vx component, my Vx final should equal my Vx initial because I've neglected, I'm taking out x component acceleration. There's a lot of things that, you know, can get factored out of problem solving. Okay. Figured this one was a timely example.
No.
You stand on top of a high rise and yeet your physics textbook off the top of it.
How come you actually put the word yeet? Can we yeet ourselves?
Because I have to be somewhat professional.
Accurate.
I'm on top of high rise.
Do you know how many Eagle 360s I'm gonna have to file? every day?
You should have used this example.
I have it recorded too. I will send them a recording. When you try to say, oh, I didn't say that, yes, you did, I got it.
No, I didn't say
She didn't say herself. Society went, she just said not.
It's not the physics textbook.
So there's only you in the physics textbook up there.
We didn't say that.
Process
We
elimination.
didn't say that. You don't think she has her phone on her? Come on, come on.
There's a recording of our voices. It's
Oh, telling other people.
Yeah, yeah.
Oh, yeah, you can't tell other
I don't know.
She'll get a new one.
people. Dude.
It's a water bottle in my browser.
Well, now that my afternoon is
I have
spent
no
on
idea.
360 reports.
We're joking. I promise we're joking. I'm just joking.
It's a joke.
Speaking of which, have you guys been getting your?
Yeah, I hate Elmo. He's so annoying. I wish I could tell
Are you
Elmo.
all still messing with Elmo like you were last year?
Oh, if you tell him that you hate your life and you hate him, yeah, he calls people. Yes, Micaiah did it and she had to talk to like 10 different people and she was like, I'm gonna sue them because this is supposed to be anonymous.
The question is. Then you see someone walking in one hand. You're like twice the distance. What do you have to do to the velocity to make sure it ends up there?
Tell them to throw it real hard.
Throw it harder.
To
Increase your
please.
initial velocity.
Exactly. If you make the example something that the students can interact with, they get the point.
Maybe throw something bigger.
It's gonna be harder to increase the velocity because you're gonna have to think about muscular force, how much mass you have to behind
Say that as
throw.
a joke.
Huh?
Say that as a joke.
Yeah. Okay, so, but how can you prove that mathematically?
Just let it go.
What's an equation?
It's kind of like yesterday.
Yeah, it's like that Rick and Morty thing. What's the square root of this number? And Morty goes, at least 9.
Yeah, Spencer, he's
A, B, C, D, E, F.
Okay, is it the equation we just saw?
Yeah,
Throw
so,
it in physics textbook outside.
you know, for example.
I
what
haven't
if
asked
we-
Paige yet. I haven't asked Paige. I can ask Nikki to draw the ask Paige.
There you go. I'm just giving out really fast.
I'll ask Nikki to ask Paige. She should stay at home on the couch.
How can this equation be made more simple?
We start at 0.
Huh?
Do we start at 0?
Well, kind of. There is something in here that could be 0. What is it? No acceleration in the x direction.
So it's 0.
Yeah.
Okay,
It's Friday.
He's thinking about creepy plans. Friday.
and so this would be your first distance, but you want to double that distance. The time of flight's going to be the same. So let's say we now have our second distance, so this will be 1.
Yes. Wait, okay, we can try that. Oh. We're being pirates.
And then we realize a couple of things.
Oh, Kamisha wants us to be princesses.
I'm not.
You don't have to be princesses.
Figure it out.
Mushu.
And the time of flight's the same. So if I go ahead and plug this, there are a couple ways you can look at this. I can either plug in my 2 times delta x1, twice the distance.
What are you being?
The only way for this to be possible, if delta t2 equals delta t1, so I can go ahead and put in delta t1, the only way for this to be possible is for the initial velocity x2 to be 2 times the initial velocity of x1. You can also do a ratio. How do you set up a ratio? Divide. So I could say, well, delta x2 over delta x1.
Tucker does.
delta t's are the same. So then those can cancel out. And I know that this ratio has to equal 2 to 1. So that also shows you that you're going to have to double that velocity. They don't always end up this nice, but they can.
Where does he get these things?
I was gonna use a different one.
Yeah, you can double the velocity, but if you were doing this on a homework, you'd have to prove that. That, or you get a group of people that go to the top of high rise and start pegging people with objects.
I'll choose the second one.
Pegging
No,
people with
I can't say
objects?
eggs.
I noticed a lot of people.
What?
A lot of older people.
I
don't
zoned
know
out
that
for a
word.
second.
My parents don't
If
use
you do it as hard as you do,
it.
it
I
is.
just use it. I have no idea what it means.
But it was
No,
Like approximately like
the
220
final
pounds.
velocity of its descent would be different. But the only thing that would change is you wouldn't throw it as far.
We're like 227 pounds worth of.
Who are you throwing off the building?
Now you say that, that's a problem.
How fast am I running?
No, no, 227 pounds
Need some-
really
Grabs
specific.
behind his shirt and he just.
And who is 227 pounds?
Me? What? Evo wanted to like just test it for food purposes.
Purely
Are
for.
the three of you gonna throw him? I don't see this happen.
No, I could do it.
Do you not think I'm strong ever?
Not that strong.
I could lift him up and at least drop him.
What if we push? How much acceleration do you want back?
So you guys are coming up with a plan and logistics.
So logistics. I would hit more people if I had something bigger.
Something bigger, not necessarily
Like 227
heavier.
pounds or something.
Why don't you just build a slingshot?
That
For
I can
the
send it to her.
227 person? Or I meant thing.
You know, it's not nice to call a person out for their way. But you now gives him carte blanche to do it to you.
Came up with it.
No, it was, yeah, I don't care. It's usually, honestly, it's not bad that I weigh a lot. It's almost a good thing. Yeah.
Okay.
I know.
When I get in
It's
trouble
not.
for throwing something
A
up
lot
the
of
top of high rise,
baby
I'm
fat
like,
still.
that was your idea.
No, I'm not, I can tell you how to do it. It was an experiment. From there, if you turn it into an experiment, that was your own fault.
Why are you throwing your
Yeah.
textbook on high rise physics?
No,
If you actually have a second chance, you can.
But I'm trying to give it to you.
Let go. You're seriously not gonna get there?
So like if you're midway falling, like I don't want
Okay.
to just laying on.
So-
I'll die.
You'll find that I make fun of problems in physics textbooks because they're always kind of ridiculous. So there was a problem in the textbook where it was all about you're firing arrows over a fence. I'm like,
Why would I do that?
I don't know.
I want to kill my neighbor. It yaps all the time.
Okay, so the way I read it is apparently for some reason you're attacking your neighbor's backyard.
Their
While
dog.
doing so, you decide to cosplay Lord of the Rings. Apparently, the schoolwork has caused a momentary psychotic episode.
Literally.
You're firing arrows from a bow over the wall that surrounds your neighbor's backyard. Before the police arrive and tase you, your arrows fly at an angle of
So
45
cities
degrees.
in Nebraska.
Find an expression for the maximum height of your arrows in terms of initial velocity and gravity. So your mathematical expression can only have initial velocity and gravity in it, your letters.
Why does this actually kind of make sense in this way? Like I can actually visualize this in my head.
Make use of the fact that the sine of 45 degrees equals the cosine of 45 degrees equals 1 over the square root of 2.
No. Too hard.
Okay, so
This is B. No, this is B.
For those of you taking genetics
Wait,
and
wait,
physics
almost
in the same
identical.
semester, a psychotic break is very possible.
Period.
What you're in right now.
And just think, you guys are under the microphones that work.
We're just entertainment.
I'll look it up.
There's your initial velocity vector. Jana, are you gonna be at the hospital tonight around 4:30?
Possibly,
Yes or no?
yes.
Shit.
What are you doing at 4:30?
Apparently getting stabbed by Jana.
Deny that's HIPAA.
I can say
You
it.
can confirm
Yeah, he can
with
say it
me.
only once.
She'll be there. Be there. She'll freak you. Be scared.
Are you a phlebotomist?
I'm just afraid of like, I missed it. I missed it.
She's good at that.
Training.
Yeah, but there's always like the vindictive, like, oops, I missed.
So just
Jana's
remember
good.
when you come in that you made past session required.
Next week, I'm gonna up the points to 10 points a week.
You should do it just for her. She made the comment. Each time she misses.
I'd take 10 free points, like, let's be so
Why is anyone
real.
complaining?
If you do it for everybody, then I find out you guys correct your own classmates quite well.
What? She's gonna slap me if I correct her.
She's
scared.
Please
I'm scared.
don't.
I get scared.
I do.
I do can't say that stuff. No, he doesn't believe it.
You can try any of the kinematic equations. You'll find out that there's little water to the solution. So let's start with,
Do you want to try on my phone?
Take my lock over here.
we'll start here. Now, you have to think, the arrows are gonna have an initial velocity coming off the bow. Hopefully, they're hitting the ground on the other side, not your neighbor. So
I thought we were aiming for the neighbor.
you are, but you're a bad shot.
Oh.
What?
You're in a psychotic break. You're not exactly aiming well. So the final velocity, wherever it strikes, is gonna be 0. And besides, it doesn't really matter where it strikes, you're still gonna get an apex in flight. Now, you change that to 0 minus 2g of y. And of course, we said the down direction is negative. And to everyone except Jana, gravity exists.
Yep. That's all right.
Okay, so. We can now take everything, so we can say 2g delta y equals
And then ask it to explain.
the initial squared.
Be like explosive, like.
This is going to equal
Sometimes you gotta tell it.
the initial velocity sine of 45 squared, which we make use of the fact that sine of 45 is 1 over square root of 2. So we have that.
What? Is that
I would give it
Fine, I'll take Mrs. Cup with her. I'll take Mrs.
I mean, but yeah, the reason I make fun of him is problems in physics textbooks are like problems in like high school math textbooks. Johnny buys 30 watermelons. Why?
Maybe he's having like a backyard dash.
What I love was I was in high school with a person, they go, you buy 5 cookies. John takes 3 of the cookies. What does John have? Broken hand.
Wait, I have a question. Is it, when we do the sine of 45 thing, shouldn't it just be VI, no Y?
No, it's still Y. It's still the Y. You're looking at the apex of flight. You're only worried about the Y direction.
Sure.
Oh, yeah, never mind. You're right. You know, I know what you're talking about.
Like, it doesn't make sense.
Mommy never learned physics.
These are my biggest supporters.
There we go.
Sonia, yeah, I was just gonna say Sonia for president.
But,
For sure.
so if we think about it,
Physics easy. Make physics easy.
That's her.
So you're telling me sine of 45?
Make physics illegal.
Sign of 45.
Because you scroll it, it says it in the.
so now what happens when you square this?
You get rid of that square root.
I would agree.
Never have.
Square the velocity over what?
Squaring it, so we get rid of the square root.
2.
Yeah.
Okay, so this is,
Wait, why did we get rid of VI?
I would actually.
now,
It looks like
we want to figure out delta Y. This will tell us how high the apex is because that V final is 0. Divide through by 2G and we get 4G on the bottom. No, 14, 4 times gravity.
I was like, more grams of what?
Oh, so that's like the answer you didn't give me what VI was?
Yeah. Oh, darn it, I keep putting Y in there.
Why don't I know what VI is?
It's your initial velocity.
Why don't I know that? Why didn't you tell me that?
Because you're supposed to derive an equation in terms of the initial velocity and gravity. I don't even know how you know that dance. That has nothing to do with Taylor Swift.
What?
Yeah, it's the only thing you
We
listen
go
to is
home.
Taylor Swift.
We don't, no, I don't. I show you my blank.
In my grant.
Yeah, get it right.
I still love the fact that the first year, you and Eva had a war going on. Then you'd come back in the room and she'd have metal playing.
Remember when you said you'd fail me if I wore another Taylor Swift sweatshirt, so class?
no.
Because you had an entire wardrobe of
Why
them.
the hell am I bringing it up? Yeah.
I have like one that I actually like now. The one where did you
Yeah.
Once it gets cold, you'll start seeing them again.
Now, to kind of answer the question you were starting class with, apparent weight.
So,
We started class with what?
So there's your actual weight,
it's a safe way to live.
and then there's your apparent weight based off the situation you're in.
I fear.
Just getting kids.
So
Get in the way.
if you're telling me before class that you don't understand the material, and then all you're doing is chucking stuff at people during class.
I said things, look at your phone.
Okay, so
Your bad shoulder.
Pay to win.
okay, so say you're standing inside, I don't know, an elevator.
Ooh, elevator and high rise.
No, not one you're gonna get stuck in for
I
5
am taking
hours.
notes.
On our ride up to the roof to the
Sierra's Appleton.
You're accelerating upwards. Now,
Wait, what?
No.
Did you have fun?
No. She's just not taking
you're
her
gonna have your
baby.
gravitational force, your weight. But if you're accelerating upward, your normal force will be bigger or smaller?
What? I'm so confused.
So in calculating that normal force is how much you apparently weigh when you're accelerating upwards. So how do you figure that out?
Don't know ever.
Um,
Wait, ask me these questions.
So is that like a house?
Are they not canceling out? They're opposite.
Nope.
Okay.
Two blocks.
Oh, I know.
No, I think it's a diagram.
Do you know? No, it was just funny. You're like,
It's like a diagram.
I was just laughing at her because she was like, oh, I don't know.
And because we're accelerating, what does this equal?
Max.
Acceleration.
What do you do with those two?
Multiply.
Multiply. Between the two of you, we were really close.
No, the 8. You have to put the 8. Max.
Because we're, so you know, sum of forces equals 0. That's for a non-moving system equal, or a non-accelerating system, or equilibrium system. But now we're accelerating. So now we have to do, we cannot equal 0 anymore. It has to equal mass times acceleration. So Newton's second law.
So mass does. She's so good at drawing.
So one thing I'm going to do to help myself is I'm going to set positive y. So that means my normal force will be positive. Mass times gravity will be negative. Mass times the acceleration. The normal force. So the normal force is going to equal your mass multiplied by gravity times the plus the acceleration. So your apparent weight goes up.
So I'm heavier on the.
On an elevator going up, yes.
Oh, this was an elevator.
Huh?
This was an elevator?
Yeah.
I'm fatter
What do
on
you
an
think it was, a
elevator.
door?
It's crazy.
A magic door?
Building.
So you're okay. When did you walk through a door and the door started accelerating upwards?
Elevator door.
My dreams.
No, but the max is 4. I'm around.
They make medication.
What?
I got like 1,000. It's not bad.
I go through doors, man. I don't know.
In all fairness, I did say elevator. You're too busy throwing things at Natalie.
Oh, poor Matt. Don't worry, I threw it back at her. Yeah, but tell me it wasn't a good thing that I got your attention, right?
It wasn't a good thing you got her
It was a
attention.
good thing. Ask her. She's happy. She saw it.
Okay, so we're gonna look at the same situation.
Yeah, no, as long as it's good. Yeah. Bad ones hurt you, but good ones, like, you can do nothing, or they get you through.
No, I have work.
Just like everything else.
Yeah. Positive y is gonna be that way. Which way do you think we're accelerating now?
Down.
Down. Okay, so your personal gravitational force is still gonna be the same. Normal force, bigger or smaller? Smaller. And so, what we do now is again,
Just so you can say that you were.
so, okay, so normal force will be positive, negative m times g equals negative m times a.
Is it because we're going down?
Well, yes, so you see the way the acceleration is pointed? You see the way I pointed positive y? So the acceleration is negative.
Oh, okay.
So this is going to be normal force, should equal mg minus m times a, and gravity minus acceleration. So Now your weight is decreasing based on the fact that you're accelerating downwards. So if you're in free fall, you weigh nothing.
Skinnier when I'm going down.
Jump on the scale.
So that's why one, not that one would, but why one would jump off.
You go 360. I'm really concerned about it.
Not that one would, I was just saying hypothetically.
So let's use the example of bungee jumping. You jump, you're free falling for a period of time.
So I'm
At
skinny
that
when I'm
time, you weigh
bungee jumping.
nothing.
Speaking of which, I want to see if you guys are smarter than the average college student.
Oh,
No.
Okay, so
You are the average.
no answer.
there used to be something called the Darwin Award.
What?
What?
Yes.
Can you repeat that?
There used to be something called the Darwin Award.
It's still a word.
Evolution.
I thought you said
If you did something stupid, and you got massively injured or worse in the process, you got a Darwin Award.
I should have gotten one last homecoming.
Natural selection.
So there was a story of this young man who's trying to celebrate graduating college. Decided to bungee jump off his dorm. Now let's just forget the fact you're gonna smack the wall.
Yeah, tried to bungee jump off.
Sounds
his
kind of
dorm.
fun.
I want you to tell me the problem with this. This young man said, the dorm is 12 stories high.
Oh, no. Oh, no.
I need a 13-story bungee cord
Oh.
because I'm on the roof.
My type of
Wait,
man.
what? 14
What happened
stories?
to it?
He hit the ground.
Yeah.
That's what happened to him.
Congratulations, you guys are smarter than the average college student.
Did he
That's
get
the
a Darwin
average.
Award?
Yes,
Did he die?
I'm not saying.
He so
Is he
died.
Business
alive to
majors,
get
man.
to Darwin?
I got
Yeah.
hurt playing
Oh,
football.
yeah.
Does that
Yeah.
give you a Darwin Award?
Art students for sure.
So, you see, doing the math is really important.
No, dude was just
I
stoned.
argue that common sense is more
I don't
so.
know, if it was me, I would have done like.
Yeah, but in
four
physics, we
stories.
don't use common sense, so if you don't have any, please use math.
I don't have
Okay,
common
so
sense.
here,
You're
I have
actually
common
above
sense
it.
now.
we're gonna work on the apparent weight of a person who's
I'm
42
like,
kilograms, that's their mass, traveling in an elevator in each of the following situations. The magnitude of the elevator's acceleration is gonna be 0.460 meters per second squared in each case. So the first one, the passenger's on the 15th floor and has pushed the button for the first floor. Question, which way is it accelerating?
Down.
Down. Okay, so what I'm gonna do. Wait, how much is 42 kilograms?
42 kilograms. It's like 42,000 grams. Roughly.
Yes, it
Am I
is.
wrong? How many?
You're not.
42,000 paper clips.
It's like 86 pounds, something like that.
Yeah, it's a small person.
Dang.
Maybe it's a kid.
Maybe it's a grandma.
Less unattended.
It could be a very chubby 4-year-old. Don't know.
And you just send them on the elevator?
Alone?
They probably sent themselves.
I have
Mom
to
and dad are
ask,
going, where'd they go?
do you know the comedian Gabriel Iglesias?
Yes.
Fluffy.
Fluffy.
Which level of fatness are we rating this kid?
That's like an obese 4-year-old. That's not chubby.
Oh, Mom, you coming?
So the down?
That's a
Yeah.
really big kid.
She's only
But-
7.
So what is gonna be the apparent weight of this person?
No way.
It's gonna be
This could also be a college student who needs some sandwiches.
horribly down.
I'm like, how big is it?
Yeah. Oh, she weighs like 9 pounds.
So we're gonna have E minus VT. And this we have the negative mass times acceleration because the acceleration and the y are opposite directions.
What did you say?
And so from here, So the apparent weight is gonna be,
So we're solving for the normal force?
yes, because think about it, if you're not accelerating, your normal force equals your weight. In this case, you're accelerating, so if we calculate the normal force and it's either larger or smaller, that's gonna be your apparent weight compared to a system that's not moving.
So here's my question. When I said earlier, we're solving for a normal force and you said no.
Then I didn't hear what you said.
Oh, okay.
Always remember, my years
These
are
are
42 years
winners. We're
old.
winners,
I used to work security for rock concerts.
Ooh. You did what?
Yeah, I worked security for rock concerts.
So my guess is.
Two reasons.
Which artist?
man. You were gonna say.
Let's see, Creed, Nickelback, Pearl Jam, Dave Matthews. Yeah, but there's a couple of reasons for that. First off, I'm large enough to make people think twice. I'm also extremely non-aggressive, so I was good for insurance.
Wait, is this like after you're like?
No, that was before. That was when I was.
You've lived a
like
crazy life.
23, 24.
For real.
20-year-old you.
Yeah,
You like
Like, yeah, so did you go undergrad, monk stuff? Monk stuff.
no, I undergrad, trying to figure stuff out, worked security for a while. Then the monk stuff.
Oh, okay.
Then I saw things
That's
like
okay.
on the inside that I was like, oh, this is not what I thought it was. And got out of that,
Are you in like you're in a cult?
That's his grape jelly he saved for after lunch.
Catholic Church cult.
Yes.
I guess it
No,
depends on
I
the
definitely
description.
should if it wasn't.
What?
Are you in like an
Yourself
NDA?
on
You're not disclosing
It is.
What information?
about the inside of your.
Oh, I can disclose it, but I'm not gonna do it on recording and it's not nice.
Pause the recording.
Pause the recording.
I wanna hear your lore.
We have to get through stuff.
No,
Says who?
do we though?
Just finished this one.
Besides, if I actually tell you, you'll be sad.
That's okay.
No.
I'm already sad. We're science
Today's
majors.
Zoom session on the in-person too, so we can just save
We've
this.
taken tip classes.
I
We know what
suppose.
it's like to be sad. We've taken immuno exam.
Music session of my life.
So, in part B, which way do you think we're accelerating?
We're still going down, aren't we?
Well, the first one is going down. For this one, let's see, slowing down, so it's slowing down as it nears the first floor.
We're still going down.
So it's decelerating, so the first acceleration was down. When it begins to decelerate, the acceleration flips the other direction. Think of being in your car and you're slowing down. You have an acceleration that moves you. When you start to slow down, the acceleration goes the other way.
And you lean forward when you're coming to a
Yeah,
stop sign.
that's because your inertial reference frame has not adjusted to what the car is doing yet. So the fun thing is if there was no friction there or things like a dashboard or windshield, you just keep going. You know, like when you go around a turn and you grab the handle. So again, if the door wasn't there and there wasn't friction holding you in the seat or a seat belt, when the car turns, your vector would take you to go straight. And you just come straight out the door.
You seem to enjoy this thought a lot.
Okay, so. The acceleration is one another one.
Okay.
I'm in it.
We solve it the same way.
You go to chemistry, that's all.
I'm not even.
Yeah.
How much time off do I give my child in my life?
This time, by the way, acceleration is
But
pointing.
not too much that he can't talk to me. He meows.
Have you ever felt that thing when an elevator slows down really fast and all of a sudden you kind of want to buckle because you're like, oh.
What's the sweet spot?
No.
What is the sweet
That's
spot?
your
really
new-
jump in the
that's-
elevator.
That's your new apparent weight and your legs going, I've never held this before.
You're telling me I'm getting heavier now?
When you're accelerating in a proper direction, yes.
My legs are so strong.
If you were to accelerate in the proper direction, your entire inertial reference frame was to accelerate you in the proper direction, yes, you're gonna get heavier.
Is this like when I'm coming down from like the plane is landing? That feeling?
I'm gonna have to.
No, well, usually no, it's more when the plane is taking off and going up. And all of a sudden you feel like super pressed.
What about that feeling when the plane is landing right as the wheels are touching the ground?
Usually coming down, you feel lighter because
Flying and coming down.
Same.
It's literally a physics.
How many units?
There, that's my name.
It says you. Yeah, I do need to go.
so now your weight is 431 newtons.
Whoa, when did this happen?
Yeah.
So bad. Okay, I'm ready to hear now.
GTA.
You finished this chapter.
Yeah, we're going on to the next chapter.
Really, can we go?
No,
We have 6 minutes left.
no.
Okay. Is there no?
You need to
add
mentally
to
prepare
that?
yourself. No, there's no slide.
You need to mentally prepare yourself, I think. Circular motion. So, you know how we've been doing kinematic equations in V and A, and X and Y?
That's what we've been doing. Oh
Well,
my
now we're gonna be working towards the same equations in terms of theta and omega and alpha.
So you hate us.
So like your delta X becomes a delta theta, and your omega is your angular velocity. And then you have to realize that the linear acceleration of a circular motion is centripetal, so always towards the center of the circle. If you didn't have, imagine you're moving in a circle. If you didn't have an acceleration constantly pulling towards the inside of the circle, you'd fly off straight.
So it's like a miracle.
What? Yeah, there has to be a force keeping you in the circular motion. That's, you call it either radial or centripetal force. Okay. Angular displacement. This is going to be analogous to your delta R. Similar to, same idea. So let's just say on here,
It's like.
it's not really a center. We'll go from the center of the circle, we're gonna have that vector. Let's say we have that vector. Okay, so this is your initial position. That's your final position. So you can call your X and Y. And so then on each one of these, you have your initial angle. Your final angle. So your displacement around the arc is going to be theta final minus theta initial, which is so that's your angular displacement. Your omega here, now it gets to your velocity. So just before how velocity was delta x over delta t or delta r over delta t, this is going to be delta theta over delta t. It's the rate change of time. It's the rate of change of your angular displacement. I'm not going to go. I mean, all of these, of course, have their instantaneous versions. So remember, just like your linear velocity and acceleration, these all have their instantaneous versions. And when I saw this one, I laughed for like 20 minutes.
Yeah, that was. Yeah, we just tackled them.
Oh, calculator was in radian. You know, there's like the.
Yeah, but see, there's a couple of reasons that's funny. First off, I think that's a real feeling. I was confident and then,
Wait, can you go back up?
If that happens, will you give us some points back?
no.
Second off, how do I make sure it's not in radians?
Well, be careful because on this one, sometimes you're gonna have to make sure it's in radians.
Why?
Because we're gonna be doing.
Angular motion is, like, for example, your angular velocity is in radians per second.
Where's the thing?
So, okay, so question, one full revolution is how many radians?
I don't know. 1 radian.
Two.
6.28.
Close. Not close.
So, so one full revolution all the way around the circle is 2 pi radians.
Oh, circumference.
Spell that word.
You don't know what circumference is?
Oh, I know what circumference is.
That's what I
I
said.
heard extra letters in there. I heard circumference or something like that. But, so it's like 2 pi radians is a circle. Pi radians is 180 meters.
Yeah. It's a degree. Of course, it's in.
I'm thinking right now, man.
This is what it reminds me of. It's circle. It's one cool thing.
I get it. We can do it here on Friday.
Yes. It feels like a Monday.
Oh, the exercise.
This has been the longest week of my life.
Last week was.
I was like, oh man.
Probably
gonna have I could already feel it. I was like,